When you first learn programming, especially when learning C, C++, or perhaps Rust, you may hear of dynamic and static libraries. They offer different solutions to the same problems, and they both aim to provide code that is reusable for binaries. Say you have a program that has a function in a C or C++ file with function foo, and it contains some code. You compile the C or C++ file into the program, and you decide that you want to use the same function that does the same exact thing in another project of yours. You could put the C or C++ file containing the function definition in the other project, but this can be a hassle, especially if you have a ton of C or C++ files, which provide a lot of functions. This is where libraries come in. You can compile all those files providing those functions into a single file called a library and link it to the program. Note that you can make different libraries which provide different functionality and data, then link the libraries that you need in the project. This is the functionality of libraries, to easily reuse code that you can use for a different project. Or you can use one provided by a different project made by different people to use with your project. This is what most developers do, even when they think they aren't. More on that later. Great, so code can be reused. But what is the difference between dynamic and static libraries, and are there any good reasons for using one over the other? What use cases are for each type of library? Well, dynamic libraries are reusable code that gets linked against the program. The library's data isn't actually included in the program, but the program will know where to search for the data if it isn't already loaded into RAM by another library process. You can update this type of library, and if the ABI doesn't change, the library will have new data, and the binary linked against the library will use the new data. However, if it can't find the library, the binary will be unable to run. So the library needing to both exist and being able to be found is a hard requirement for the binary to actually run and do what it needs to. This can cut out disk usage, and the data will now be loaded into RAM, being able to be used by any project that needs the functionality. Static libraries, on the other hand, are compiled into the project, meaning that when you link the library with the project you are making, all that reusable code is copied into the project, now a part of your produced binary. The benefit of this is all the functionality that the binary needs is essentially baked right into it, not relying on other files besides what it already needs, such as images and audio data, which would be typical for a game. The binary will basically be portable and can run on any system that supports the binary format, like ELF or PE. You will be able to update libraries on your system and not have to worry about things breaking, as no program and library depends on that library you updated. The functionality is already in the binaries that use it. However, this always leads to increased disk usage. This is also used for pulling in subprojects, compiling static libraries, and including them in the main project. So what do most projects use? A combination of both types, but it's mostly dynamic libraries. If you're on Windows or familiar with it, when you download a zip file of a project and unpack it, you will often find a lot of DLL files next to an exe file. DLL files are dynamic files. Well, why are DLL files in the project? Why not just use static libraries to reduce the amount of files in the project? This can be great for developers that want to drag and drop new libraries without having to recompile the project to get new functionality. But I'm going to be honest and say that I don't see this appeal. I would just recompile the project down the road, so I just go with static libraries. However, this would be futile because the dependency on dynamic libraries is still necessary. And this is what I touched on earlier. Even if you decide to not rely on libraries, you will still need to rely on some form of libraries, often dynamic ones. You'll need to rely on the operating system's API calls and a version of the C or C++ runtime. They're often dynamic. On Windows, they often have to be packaged in the project or in the folder containing the exe file, or else the libraries or programs will fail to launch. I've personally been burnt when it comes to this and had to figure out the DLL files I need to package for the exe to work. On Unix, all these libraries on the LSB compliant systems will be included in user lib, and a combination of dynamic and static libraries are included. Almost every library and program on Unix depend on libc. I can't recall a binary that doesn't. Say you upgraded libc and nothing else and decide to reboot. There's a chance that you won't even be able to log into a TTY. This because the library had its API changed, and this prevents binaries from functioning. This is common with GNU's glibc. This happens with other libraries too, not just glibc, but glibc, a bunch of binaries depend on glibc, so it's more of an issue. Furthermore, what if you don't have a library a binary depends on? Well, the common answer is to get the library yourself. But should things be this way? I don't think they should. I think dynamic libraries have too many issues on Unix, and while I see the appeal, static libraries should be used instead. Too many binaries depend on dynamic libraries, and if the library name or API changes, or if the library simply isn't on a system, the binary fails to function. The solution to this is static libraries. If dynamic libraries were done away, binaries can have functionality dependent only on itself rather than something else that can change or break, or can't be found. This could remove the need for libraries entirely for the regular user who only wants to run programs and not compile anything. For developers, the user lib directory is full of dynamic and static libraries. The dynamic libraries can be removed to save space. Another nifty feature of this is that projects linking against GNU's glibc could potentially be ran on a system with muscle libc. Yes, I'm pointing out Steam. Fuck Steam. Lastly, it would remove the need for file extensions in the library directory if libtool archives are removed as well. You could just have libfoo without the .a extension, as it will always be static, and not dynamic or libtool archive. However, there are a few problems that make a static library-only system impossible for now, from what I know. First, proprietary applications on Unix depend on a lot of dynamic libraries, and should those libraries be done away entirely, will result in those applications failing to launch. Another issue is that a lot of projects ship only dynamic libraries. Thus, these projects would need to allow for all libraries that are made to be in a static format. Lastly, on Linux, you will have the ld linux.so library. Getting this to be static may take a lot of work, but I am unsure if this is even needed. The library, from what I know, just loads other libraries, or helps with that process, and if you have a static-only system, then perhaps this library isn't needed at all, but I'm unsure. However, I think we need to get rid of dynamic libraries, at least on Unix, but it could be beneficial for Windows as well. It was a necessary idea for the time to save on disk usage, but a static library-only system wouldn't take that many more gigabytes depending on how much stuff you install, even on a 128 gigabyte system. Hopefully I may make case well enough, but I am unsure. I'm also open for discussion and see your thoughts on this matter. I personally hate all the current issues with dynamic linking, and fearing a glibc upgrade will break my install. I take more disk space over ABI issues. I don't want to stay on a FFmpeg version and fear the old libav files won't be found. Let me know what you all think. With that, please check out my Patreon, link in the description. Thank you, patrons. They will show on screen now. Isekma out.